Good morning, children. In my previous video we had done composition of matter, properties of molecules of a matter, and we had discussed the three states of matter: solid, liquid and gas on the molecular basis. In this video, part 2, let us start with these question answer session. These are to be written in your notebook. 3 questions. These are to be written in your notebook. The question along with its answer in your physics notebook. Alright. The first one, define the term matter. What is it composed of? So if you have watched the previous video carefully, answers to all these questions I had explained. The first one, you will be writing it here. I have written the answer as well. You will be writing the answer this way. Matter, anything which occupies a space, has mass and can be perceived by our senses, is called matter. Example: air, water, iron. What is it composed of? It is composed of molecules. So this one has to be, start with the question answers in your notebook. Physics notebook. Second one says 3 properties of molecules of a matter. If you remember, we had done 4 properties. Of the 4 properties of molecules of a matter, you can write any 3. Like the first one, if you remember, you can refer to your book as well. The first one is molecules are very small in size. The second one, they have spaces between them, and these molecules are in constant state of motion because they possess kinetic energy. Therefore, you write any 3 of the 4 properties which we had mentioned. The fourth one was, these molecules attract each other. That could be the second answer to the second question. And it is given on page number 3 under characteristics of molecules. This is given on page number 3 under characteristics of molecules. This is on page number 2. If you have difficulty, it's on page number 2 in your book. Please refer to your book and answer these questions in your notebook. First answer, I have written it here, the first part. Anything which occupies a space, has mass and can be perceived by our senses is called matter. And you can give example. And for the second part, what is it composed of? It is composed of tiny particles called molecules. Now the third question. The 3 states of matter, solid, liquid and gas, on the basis of molecular model. If you remember, I had made tabular distinction between the 3 states of matter. So you will draw the table and write down the distinction between solid, liquid and gas on the basis of molecular model. In your book, if you refer to your book, it is given on page number 6. So it's given on page number 6. Refer to your book and write it down all neatly in your notebook and make sure you learn it. Now we will continue with the chapter. Alright. Now let us see the change of a state of matter. The process of change from one state to another state, that is either from solid to liquid or liquid to gases or vice versa, by absorption or rejection of heat at a constant temperature is called change of state. The temperature remains constant during the change of state. Alright. So as you can see in this flow chart, the change from solid to gas directly is called sublimation, and in the process heat is absorbed by the substance. Similarly, the change from gas to solid directly is called deposition, and in this case heat is rejected and the substance changes from its gaseous state directly to the solid state. And there are some examples such as naphthalene, ammonium chloride, camphor. Alright, we'll be reading about it in detail. Right now just look at this flow chart and see how the change of state takes place. When heat is absorbed by a solid and if it directly changes into the gaseous state, it is called sublimation. And if heat is rejected and it directly changes from the gaseous state to the solid state, it is called deposition. Similarly, if heat is absorbed by the solid and it changes from solid to liquid state, the process is called melting, and the constant temperature at which the change takes place from solid to the liquid state is called the melting point of that liquid. That's of melting point of that solid. For example, for ice, the melting point is, for ice, its melting point is 0 degree Celsius. And similarly, if heat is rejected by a substance, by a liquid, it changes into its solid state and the process is called freezing. During the change of state from liquid to the solid state, the temperature remains constant and that is called the freezing point. Similarly, heat absorbed from the change from liquid to the gaseous state is called vaporization, and the constant temperature at which the liquid starts to convert to the gaseous state is called the boiling point of that substance. And similarly, we have, if heat is rejected, it is called the condensation point. So this is the flow chart which shows the complete cycle of change of the state of a substance from solid to liquid, liquid to gas, and vice versa. Alright? Now let us perform an activity. Let us perform an activity to show the process of melting of wax. In this experiment, wax is taken in a test tube which is immersed into a beaker containing water, and this setup is heated over a burner. A thermometer is clamped to the test tube which contains wax and which records the temperature. Alright? Therefore, the time and temperature is recorded when the wax is heated over the flame of a burner. It's heated indirectly by placing it in a beaker containing water. Otherwise, the test tube would crack if it is heated directly over the flame of a burner. Therefore, it's heated indirectly in this manner. The time period is the temperature, and the time period for it is recorded for the experiment. At the beginning, it is at 25 degrees Celsius room temperature. Then, after 1 minute, the temperature which shows on the thermometer is 30 degrees Celsius. After 2 minutes, 35. After 3 minutes, 40 degrees Celsius. After 4 minutes, 45. It goes on this way. After 5 minutes, 50 degrees Celsius. After 6 minutes, 55 degrees Celsius. And then, what is seen is that the time lapses 6 to 7, 7 to 8, 8 to 9 minutes, but the temperature remains constant at 55 degrees Celsius. Then when it comes to 10 minutes, the temperature rises to 60 degrees Celsius. Again the temperature starts to rise here. But over here you will see the temperature remains constant even when the heat is supplied. The temperature which is seen in the thermometer remains constant at 55 degrees Celsius. This temperature, this temperature 55 degrees Celsius is called the melting point of wax. The temperature which remains constant during the change of state is called its melting point. Therefore, melting point of wax is 55 degrees Celsius. In this experiment, the melting point of wax is 55 degrees Celsius because the temperature remains constant although the time lapses here. Alright? This is called, this heat which does not increase which remains constant but causes a change in its state, that is from the solid state of the wax to the liquid state. At this temperature, you will see that the solid wax starts changing into its liquid state. This is called latent heat or the hidden heat. So, it is defined as the change of state. It occurs at a fixed temperature, and the quantity of heat given to the substance does not cause a change in temperature. This quantity of heat which is given to the substance is called the latent heat. It does not cause a change in its temperature but causes a change in its state, that is from solid state of the wax to its liquid state. Alright, the next I had explained latent heat, and now comes specific latent heat. If latent heat, that hidden heat during the change of a state the temperature remains constant during the change of a state. Therefore, the heat which is supplied to the state does not cause a rise in its temperature but causes a change in the state of the substance. If the change of state of the substance, if it takes place for unit mass of a substance, if it takes place for unit mass of the amount of heat absorbed or rejected during the change of a state for a unit mass of a substance, if it is for a unit mass of a substance, then it is called specific latent heat. And SI unit of a specific latent heat is joules per kilogram. Then melting point of ice decreases. It is seen that the melting point of ice decreases with increase of pressure on it, but the melting point of wax increases with the increase of pressure on it. So then the melting point of ice decreases when salt is added to it. When salt is added to ice, it is seen that its melting point falls down. Melting point decreases further. Decreases almost to minus 20 degrees Celsius from 0 degrees Celsius, and of it minus 15 degrees Celsius, quite low it goes. And it is called freezing. This mixture of ice and salt is called freezing mixture. And do you know where this mixture is used? It is used in preparing of kulfis. It is used in the preparing of kulfis. All of you must have had kulfis, summertime now. All of you must have tasted what kulfis are. You will see the shopkeepers, these vendors keeping it in a mixture of salt and ice and salt, and that mixture is called freezing mixture. It is used in this preparation of these ice creams. Alright, now some more homework for you. What you will do is, the first part I had explained the flow chart for the complete cycle of change of state. So you will write down that in the form of question answer in your notebook. 3 I had given earlier, so the fourth one you will write given on page number 17. Number 17, it may differ in your book. On page number 17, question number, you will answer question number 7. Alright, 11, and you will write down these definitions: latent heat, okay, latent heat, then a specific latent heat, SI unit. All these definitions should be written in your notebook. Then these points are important for the scientific reasonings which will be asked. Melting point of ice, it decreases, whereas melting point of wax increases with the increase in pressure. Then melting point of ice, it decreases, and it is this mixture of ice and salt is called freezing mixture. All these should be in your notebook. Once again, the question number 7, which is, what do you mean by the change of a state? Here it is. Write the flow chart showing the complete cycle of change of a state. That is also, the answer is given on page number 7, figure 1.8, and I have also explained it in my in this video. Then 11th question is, describe an experiment to demonstrate that a substance absorbs heat during melting without change in its temperature. The activity which shows melting of wax, that has to be written along with the figure and as I had explained. And then we have these definitions which you need to write it in your notebook. So that's all for today. Thank you.